Today we're going to talk about the inverse element, and the binary operation. So we are saying that an element A inverse, which belongs to the set of real numbers, is called the inverse of A, which is also a real number, under the operation star. If A star A inverse or A inverse star A is equal to the identity element, right, where the E is the identity element, right? So if we combine A and a certain element with the operation star and we are getting the identity element, then that element is the inverse of what? A. Or if we combine an element and then A with the operation star and we are getting the identity element E, then that element is the inverse of what? A. Good. Now let's look at some basic examples. Now in the previous video we said that 2 plus 0 will give us 2, right? Which implies this is the additive identity, right? So the additive identity is what? 0. Now what we are saying is that if you pick the number 2, right, what number will you add to the number 2 to get the identity element for addition? 0. Is that right? Good. So this is the number 2. Now we are looking for a certain number to add to the 2 so that we get the identity element E. Alright, and this thing you see over here, you can write it in short as A star A inverse is equal to E, or A inverse star A is equal to E. I'm making use of this first one, right? The first one over here. Alright, do you realize that the number is what? Negative 2. So we say that negative 2 is the inverse of what? 2. If you pick the number, let's say 5. So 5 plus what number will give you the additive identity? The number, as you know, is what? Negative 5. Therefore, negative 5 is the inverse of what? 5. Good. Also, in a previous example, we mentioned that if you have a number 3 times what number will give you the number itself, 3, and we said 1, which implies 1 is the identity element under multiplication. Alright, 1 is the identity element under multiplication. So E under multiplication is what? 1. Now, if you pick the number 3, what number will you multiply by 3 to get the identity element 1? Okay, what number will you multiply by 3 to get the identity element 1? And you realize that the number is 3 to the power negative 1, which is the same as 1 over 3. Okay, which is the same as 1 over 3. Sorry, 1 over 3. So 3 times 3 to the power negative 1 is what? 1. Or 3 times 1 over 3 will give you what? 1. Which implies 3 to the power negative 1 is the inverse of what? 3. Or 1 over 3 is the inverse of what? 3. Likewise, if you have, let's say, 4. 4 times what number will give you the identity element for multiplication? Then you can tell me that 4 times 1 over 4 will give you what? 1. Or it is the same as 4 to the power negative 1. Which implies, or it means that 1 over 4 is the inverse of what? 4. Or 4 to the power negative 1 is the inverse of what? 4. So the number that you operate on 4 to get the identity element is the inverse. So this is the inverse, right? That's the basic idea about inverse element. So now let's pick some simple examples on the binary operation. So now this simple example is saying that an operation star is defined on the set R of real numbers by A star B is equal to A plus B minus AB. where A and B are all real numbers. Now we are asked to determine the inverse under the operation star, okay, of a general element A, which is also a real number. In any case, we are trying to, or they want us to find the inverse of what? A. Alright. And then also state the element of R which has no inverse. Then find the inverse of what? 5. This is a simple question that we have to look at. So let's see how we answer this question. Okay, let A inverse, which is a real number, be the inverse of what? A. Good. So now what we know is that if we operate the inverse of A on A, we should get the identity element. Alright, so the question now is, what is the identity element? What is the identity element under this operation? Now we don't know the identity element, but we can find it. So let's quickly go ahead and find the identity element. Alright, good. What it means is that if you are given a question to find an inverse, you would need the identity element. You will need to find the identity element. Alright, so in a previous video we learned that if you have A operation the identity element, you should get that same number A. Alright, so now if you want to relate this with the definition, our A is what? A, and our B is what? E. So wherever we find A in the definition, we put A. Where we find B, we're going to put what? E. A, we put A. B, we put what? E. Whatever we get is equal to A. Alright, so we'll be having something like A plus B. Sorry, our B is supposed to be E. So A plus E minus A E, okay, is equal to A. Let me continue this over here. So now we would have to find the identity element E. Now let's group terms. Okay, so E minus AE. So you have E minus AE on the left side is equal to A. See, you'll bring the A over here, so minus A. This will give me E. See, E is the common factor between the two terms on the left, so you factor it out. You're left with 1 here minus A. This is equal to A minus A is what? 0. Okay, so these are two terms for which E is a common factor, so I'll factor it out. I'm left with 1 in the first term minus I'm left with A in the second term. Alright, but our identity element is E, so we have to make E the subject by dividing through by what? 1 minus A, 1 minus what? A. Okay, so this is A, for which this one will cancel this. So you have E, which is our identity element, is equal to 0 over any number is what? 0. So our identity element is what? 0. Alright, so now we can go ahead and find our inverse element. Let me do that over here. Find our inverse element. Okay, A operation the inverse element should be giving us the identity element, which we found to be what? 0. Good. So we are going to use the definition over here to evaluate this. So our A is A, our B is what? A inverse. So wherever we find A, we put A. Where we find B, we're going to put the A inverse. Okay, so let's do that. So we have A plus our B now is what? A inverse minus AB. Our A is A, our B is what? A inverse, is equal to the identity element. Now our identity element is what? 0, so it's equal to 0. Now we want the inverse, so you make the A inverse the subject. Alright, so we have A inverse minus A inverse is equal to, see, we have 0 minus A. Okay, I'm grouping terms, these two terms on the left side, and then the A will go to the right side. It's positive here. When it comes, it becomes negative. Alright, so these two terms have a common factor, which is the A inverse. So you factor the A inverse out and left with 1 in the first term minus A in the second term is equal to 0 minus A is what? Negative A, like this. Now you are looking for the A inverse. Okay, so you divide through by 1 minus A by 1 minus what? A, for which this one will cancel this. And then you have the A inverse is equal to negative A over 1 minus what? E. This is your A inverse. Okay, or that's the inverse of what? A. That's the inverse of what? A. So we've answered the first question. So we use the relation A operation, the inverse should give you the identity element. And since you don't know the identity element, you find the identity element. So you find it to be 0. A operation, the inverse should give you the identity element. So you evaluate that, equate it to the identity element, and then you get the inverse element to what? Negative A over 1 minus what? A. So that is the I. Now for the II, the II says that we should state the element of R which has no inverse. Now let me write this. So the II, I want to write this one down. Now all we are saying is that this is the inverse we found. We found the inverse to be negative A over 1 minus A, okay, which is a fraction. Now we are saying that we state the element of R which has no inverse. Okay, so the inverse does not exist if the denominator of the inverse, this is the inverse, and then this is the denominator of the inverse. Okay, this is the denominator of the inverse. Is what? 0. If the denominator is 0, it means the inverse does not exist. So if 1 minus A, which is the denominator, is equal to 0, okay, it means the inverse does not exist. And 1 minus A is equal to 0 means 1 is equal to what? A, for which is the same as A is equal to 1. So therefore the element of R that does not have inverse is what? 1. What it means is that for every real number their inverse exists, except that that real number is what? 1. It means if A is 1, you're going to put 1 over here and you put 1 over here. If you put 1 over and you put 1 over here, you have negative 1 over 1 minus 1, which is going to give you negative 1 over what? 0, and therefore the inverse does not exist in that case. Alright, so the element of a set of real numbers that does not have inverse under this operation, okay, is what? 1. Alright, and let's look at the last one. We want to find the inverse of 5. See, the inverse of 5 is equal to, now we this is the inverse of A, right? We're gonna get this. So the inverse of 5 is going to be negative 5 over 1 minus what? 5. You're going to substitute 5 into whatever you cut for the inverse. So this one will be equal to negative 5 over negative 4, which is equal to 5 over what? 4. The negative takes care of the negative. So that's the inverse of what? 5. Now let's take another example. This one says that a binary operation triangle is defined on the set R of real numbers by M this is triangle. Okay, so M triangle N is equal to M plus N plus 12. Now I want to find the inverse of 5 and what? Negative 4. The inverse of 5 and negative 4. So the solution, you let the inverse of 5 be what? K. We don't know the inverse, so let's assume that is K. Okay, let's assume that is K. So what it means is that 5 triangle, the inverse, which is K, should give us the identity element E. 5 operation, the inverse, should give us the identity element E. Alright, but we don't know the identity element, so we have to find the identity element. So to find identity element, we see that M operation the identity element should give us that same M. Alright, so we are going to use, the operation is triangle. Good. So in this case, our M is M and then our N is what? E. So we're going to fix them into the definition. Our N now is E. So you have M plus E plus 12 is equal to M. Then you find the identity element E. So you have E is equal to M minus what? 12. So you get E to be equal to M minus M goes away, minus negative 12. That is our identity element. Alright, so now we can go ahead and find the inverse of 5. So 5 operation K, which is the inverse, is equal to the identity element, which we found to be negative 12. So now we're going to use the definition to evaluate this. Alright, so in this case our M is 5 and our N is what? K. So we have 5 plus our N, which is K, plus 12 is equal to the identity element, which is what? Negative 12. Then you solve for what? The inverse, which is what? K. So now this will give us K is equal to negative 12, K minus 5, then what? Minus what? 12. Then you get K to be equal to negative 12 minus 5 minus 12 should give us negative 29. Therefore, the inverse of 5 is what? Negative 29. Alright, so now let's find the inverse of what? Negative 4. The inverse of negative 4. So see, let the inverse of negative 4 be let's say P. Let the inverse of negative 4 be P. So we know that negative 4 operation the inverse should be equal to the identity element, and we found the identity element to what? Negative 12. We are going to use the definition to what? Evaluate this. This is triangle. Our M we have over here is negative 4 and our N is what? P. Then our identity element is what? Negative 12. So we have the M, which is negative 4, plus the N, which is P, plus 12 is equal to the identity element negative 12. So now you solve for P, which is the inverse of what? Negative 4. So you have P is equal to negative 12. This one becomes plus 4 minus what? 12. If you send negative 4 here, it becomes plus 4. If you send 12 here, it becomes minus 12. So you have P is equal to negative 20. Therefore, The inverse of negative 4 is what? Negative 20. Alright. Now let's look at the last example. Now this one says that the operation circle dot is defined on the set A, which contains these elements by the table below. Determine the inverse of each element of the set A under the operation. Okay, so we have to determine the inverse of each of these elements. Okay, the elements P, Q, R, and what? S. Now, for example, if we pick the element P operation, the inverse of P should be equal to the identity element. Alright, the same way Q operation, the inverse of Q should give us identity element. Likewise, R operation, the inverse of R should give us the identity element, and S operation, the inverse of S should give us what? The identity element. Alright, so now the question is, do we know the identity element? Good, we don't know, so it means we have to find the identity element from the table. So we know that for the identity element, P operation, the identity element should give us what? The same P. Q operation, the identity element should give us the same Q. R operation, the identity element should give us the same R, and S operation, the identity element should be giving us what? S. So now let's look at the table and see whether we can find the identity element. E is equal to what? Let's see whether we can find that from the table. Good. So when you come to the table, P operation, which element will give you P? So when you look at the table, you see that P operation R is giving us what? P. Okay, and also Q operation R is giving us that same Q. R operation R is giving us the same R, and S operation R is giving us what? S. Okay, so in the first case over here, P operation R is giving us P. Q operation R over here to R is giving us Q. R operation R is giving us R, and S operation R is giving us what? S. Okay, which means our identity element is what? R. Our identity element is R. So now we say that P operation, which element will give us the identity element, which is R, and then Q operation, which element will give us the identity element, which is R, and then R operation, which element will give us the identity element, which is what? R, and then S operation, which element will give us the identity element, which is what? R. That's what we are going to do. So when you come to the table, you have P over here. Okay, you have P over here. Operation S. Okay, so P operation S will give us what? R. So P operation S will give us what? R. When you come to Q, this is Q. I have my Q over here. Operation what will give us R? P. So Q operation Q will give us what? R. So Q operation Q will give us R. And then when you come here, R operation what will give us R. R operation what will give us R. So you have R operation R giving us what? R. R operation R giving us R, and then S operation what will give us R. S operation P will give us what? R. S operation P will give us what? R. What it means is that, let me write this one here. What it means is that the inverse of P, the inverse of P is what? S. And then the inverse of Q, the inverse of Q is what? Q. Then also the inverse of R is what? R. And then the inverse of S is what? P. That is what it means. So use the idea that P operation the inverse should give you the identity element, and Q operation the inverse should give you the identity element. R operation the inverse should give you the identity element, and then same in this case. But now we don't know the identity element, so you then again have to use a table to find the identity element, which you know that P operation the identity element should give you that same P. Q operation the identity element should give you that same Q, and then same for this, and also S operation the identity element should give you what? S. Good. And then we found from the table the identity element E to be what? R. The identity element is what? R. So now what it means is that P operation the inverse element, P operation the inverse element should give you the identity element, which is what? R. So P operation the inverse should give you R. Okay. Q operation the inverse should give you the identity element. So Q operation the inverse should give you R, which is the identity element. R operation the inverse should give you the identity element R. Then S operation the inverse should give you the identity element what? R. Okay. So getting this element, it means the inverse of P is what? S, which you've written over here, and the inverse of Q is Q over there. The inverse of R is R. The inverse of R is R. Okay. And also the inverse of what? S is what? P. And that's what we have over there. Alright, thanks for watching, and please, if you've not subscribed to my channel, make sure you hit the subscribe button and then click the notification bell so that you receive notifications anytime new videos have been posted. Thanks for watching.